So new topic, trigonometry. New topic is trigonometry. So let's start. So now, under trigonometry, there are three things. So this is the last topic before exams. Pythagoras theory. So number one is that we need to know that we only use Pythagoras theory. We only use Pythagoras theory. We only use Pythagoras theory to find. We only use Pythagoras theory to find one of the sides of a right angled triangle. Only for a right angled triangle. Angled triangle. If we are given the other two sides. Clear? If we are given, so the keywords here, right angled triangle, then the other point conditional, if we are given two sides. That's when we use a right Pythagoras theory. Is that making sense? Only for right angled triangle, number one. Number two, only we are given the other two sides to find the third side of the right angled triangle. That's where we use Pythagoras theory. So for example, if I have something like this here, and I'm told that this is 3, this is x, this is y, there is no way I can use Pythagoras theory here, because I said I have to be given two sides of a right angled triangle. We only apply it if we are given two sides of a right angled triangle. Let's say this is A, this is B, this is C, this is theta, the angle, okay? So to find the longest, this is the longest side, A, which is the hypotenuse. It's your longest side, longest side of a right angled triangle. That's the longest side of a right angled triangle. So to find the longest side of a right angled triangle, it comes from this relationship here, that A squared is equal to B squared plus C squared, which means A is equal to square root of B squared plus C squared, square root like this. Clear? So to find the longest side, in summary, I square the other two sides. I add their sums and I find the square root. So for example, and write an example here. If I have a right angled triangle like this, let's say this is 12 centimeters, this is 5 centimeters. So for me to find this side here, x is going to be 12 squared plus 5 squared. Then use your calculator, square root. If you do that, you get exactly 13 centimeters. It's the longest side. Are we together? Is that making sense? So always remember, when I'm finding the longest side, I square the other two sides. I add them and I find the square root. Now, if I'm finding any other side that is not the longest side, the same formula, the same concepts. So let's say this is 18.5 for an example. And let's say this is 4.5, 4.7 here. And let's say this is x. Clear? So now, because this is not the longest side, I don't add. So to find that x here, I square the longest side, which is 18.5 squared, minus 4.7 squared, like this. Then we do the square root like this. Are we together? 18.5 squared minus 4.7 squared. Use your calculators, then you find the square root. Quickly use your calculators. What do you get? Guys, what do you get?
Minus 3.
Minus. How can you get a minus? How can length of something be a negative? Did you say minus?
17.9.
17.9. Huh? To three significant figures. 17.9 centimeters. Is that making sense? What about if we have something like this? 21, 9.3, like this. So to find this side here, because it's not the longest, we say the longest side squared minus 9.3 squared. Then like that, squared. Are we together? That's the easiest part. What do you get? 18.8. 18.8. That's the easiest part. So that's all Pythagoras. That's all you need to know. If I'm given any two sides of a right angle triangle, I can always find the other side. If it's the longest side, I have to add the squares and find the square root. If it's any other side apart from the longest side, it means I have to square the longest side minus the other square of the other side, then I find the square root. That's how I do Pythagoras theory. Are we together there? Now, having done this now, we now want to move on to what is known as soccer tower. Soccer tower. Soccer tower. Like this. Soccer tower. So this one, they will never give you in the exam. You should master it. You should know it by heart. Soccer tower, and how to use it. Either to find, when do we use this? I will now give you the scenarios. Number one, we use it when given a side. So again, it's only for right angles triangle. You can write only for right angle triangles. Clear? Never use soccer tower when it's not right angle triangles. Only for this. So we when given a side and an angle of a right angle triangle. Triangle. Clear? So when given an angle and a side of and an angle to find, so we use that to find another side. If we are given that pairing and to find a length of another side. Number two, to find an angle given two sides. So if you're given two sides of a right angle triangle, clear? Triangle. So if we are given two sides of a right angle triangle, we can find the angles. If we are given an angle and a side, we can find the other two sides. Are we together? Of the right angled triangle.
So
yes, question?
What does number two say?
To find, okay, that's a mistake. To find an angle given two sides. So to find an angle to find an angle given two sides of a right angle triangle. To find an angle given is that clear? So what it means here, we'll look at this later. What it means, these two statements that I've given you there, if I have two sides of a right angle triangle like this, let's say this is 13 and this is 5. I can actually find this angle here, or I can find that angle, because I'm given two sides of a what? Of a right angle triangle. If I'm given a side of a right angle triangle, let's say this is 7.5, and I'm given that this is 30 degrees, I can find that side, I can find that side. That's what I said. Given two sides of a right angle triangle, we can find any of the two angles here. This is 90, no need to find it clear. I'm given two sides. If I'm given a side and an angle, then I can find the other two sides. Is that clear? Application. Now let's look at now certain things, certain properties of a right angle triangle that we need to know before we apply what we are talking about. So if we have a right angle triangle like this, and I have an angle here, this side is the longest side. What do you call that side? We talked about it. Which is your H. That's your H in your formula. The side where the angle is sitting is always known as the adjacent. It's where the angle is sitting. The side that is opposite the angle in question is called opposite. So it's an O in that formula there. Then this is A here. Clear? What if I have a triangle like this here? What if I have a triangle like this, and this is my angle here, and this is my H? Let's say this is A, B, C. It's a triangle. Who can tell me which one is the opposite and which one is the adjacent from what I've said? Which one is the opposite? Is it A, B, or B, C?
The opposite is AB.
AB, opposite to the angle given in question. So this is O, and this is adjacent. If you know that, then things will be easy. That's not difficult. Now, let's see how we apply what we've talked about just now. So let's bring the question. Let's bring the formula, then look at certain things about that formula. So we said, so it means sine theta. You can write that down. Sine theta, look at this formula here. It's opposite over hypotenuse. Then cos theta is equal to adjacent, A over H. Then tan theta is equal to O over what? Over A. Is that clear? Or not clear? Now, let's look at the question now, where we need to apply SOHCAHTOA. So if I have a right angle triangle like this, okay, let's say this is 32, and this is an angle theta, and let's say this is 17 for argument's sake. Now, say meters, it's not drawn to scale, meters here. So to find this side, I can use Pythagoras. I'm not worried about the side, I'm talking about the angle here. If we want to find this angle in question here, what are we given? We are given the longest side, which is H. I want to show you how you do that. And this side is where the angle is sitting, is what? Is A, adjacent. So what do we use? We want combination of AH, AH. AH is cos, this, cos. So it means cos theta is equal to, which side is the adjacent? 17. Over the longest side, 32. 32. That gives you a fraction of the angle. The angle theta now is equal to arc cos, like this, brackets 17 over 32. Now, can you do that in your calculator? If it is a sharp calculator, you press second function, arc cos. If it's a Casio, I think it has an arc cos button. Huh? A sharp doesn't have an arc cos button. You use the cos, but you press second function, cos. Then you use brackets 17 divided. Make sure your calculator is in degrees, DEG, not any other mode, clear? When you're doing this, make sure. So for all level, your calculator always has to be in degrees, DEG format. Are we together? Make sure your calculator is in degree format. So what do you get?
57.9.
Is everyone getting that? Because maybe some is newer. I want to make sure everyone is getting the same answer. Are we getting the same answer? 57.9 on our calculators. It's important that you have your say there.
No.
57. You're not getting that. Arc cos. Anyone who is not getting that? The rest are quiet. So it means everyone is getting the same answer. Because you are quiet. Okay, now, having done that, let's look at something here. I want you first to tell me which formula we are using. Then we pick it from there. So we're dealing with the angles. We'll deal with how to find the side just now. So if I have that right angle triangle, that angle we don't know, then maybe we're told that this is 14, and maybe this is 12.3. Now, my question is, what formula are we going to use? Study that. And I want someone to tell me if we are using sine, cos, or tan. Study that. And then tell me what are we going to use? What combination or what formula? Hmm? Sorry?
Tan.
Tan.
Tan. You did
Tan.
everyone, do you agree? What's the
Yes, sir.
angle is A, where the angle is sitting, then opposite or correct tan. So look at this here. Tan theta is equal to opposite over adjacent. What is my opposite here? 14 over my adjacent 12.3. So I'm saying tan theta is equal to 14 over 12.3. Again, this gives me a decimal. I want the actual angle. So theta is equal to arctan, like this in brackets, 14 over 12.3. Do that on your calculator. Make sure it's in DEG degree mode, not any other mode. Angles is always to one decimal place, unless told otherwise. Huh? Angles always to one decimal place, unless told otherwise. Are we together? So can you quickly calculate that? Calculate that angle. What angle do you get?
48.7.
48.7. Is everyone getting a 48.7 so that we can help you before we go further? Everyone, Jigo, are you getting that? 48.7 on your calculator?
Yes,
Just
sir.
want to make sure we are on the same page. Huh? Because it might be new to some. Nyasha, are you getting that angle then? Nyasha, can you hear me? 48.7. Clear. Okay, let's look at another one. So you see, is to remember this and to apply that. Then the rest of that part won't be difficult. Now let's look at something else before I show you how to find angles, sorry, sides. So if I have that, so you can, these examples, I hope you're doing them as we are doing them together. Let's say we are given, we want to find this here. And we have, sorry about it. Let's say we are given this as 60 meters. Then this angle here, we don't know. Then we are given this one here is 25 meters, like this. So what formula? Sine, cos, or tan? Figure out what formula quickly first.
Fine.
Sine. So she's quick there. That's correct. Because we are given the longest side, then this side is opposite the angle O. So OH is sine. So it means sine theta is equal to opposite, which is 25, over the opposite over the longest side, 60 like this. Then it means theta is equal to arc sine. Can do that, don't have to wait for me. What angle do you get? 24.6 to 1 decimal place. Do you agree? Okay.
Yes, sir.
Now, I hope everyone has copied that. Let's look at a different question now, where we have to find the side given an angle. So let's say this angle here is 47 degrees. And I want to find this, so right angle triangle, and I'm told that this is 9.9 centimeters. So you can write that example there. Again, we simply apply the same thing, huh? The same thing that you have been doing. So the longest side is what we want to find, but we are given the adjacent side, AH cos. So cos, do I have to say theta or I say the angle? The angle I'm given, huh? So cos what? 47. This time I'm given the angle, can you see that? Is equal to adjacent over the longest side. So it means 9.9 divided by x, adjacent over the longest side. So it's 9.9 divided by x. Then we cross multiply this, cross multiply, we get x cos 47 is equal to 9.9. Then we divide both sides by what? Because what we want is to find x. Divide both sides by cos 47. So you can write that. Divide both sides by cos 47. Like this. So what is 9.9 divided by cos 47? If it's a side, is 3 significant figures. Huh? Divided by cos 47, what do you get? 15 point what?
14.5.
14.5. Centimeters, since it's in centimeters. Making sense?
Yes, sir.
Okay. Now, let's look at a different question also. So if we have that here, and let's say this angle here is 32 degrees, and we're given this here is 28 centimeters, and we want to find x like that. So in fact, let's say we want to find x, then we want to find y. Okay, so you can write that question like that. So this is the longest side. We all agree. And this is the adjacent. And this is the opposite. So if I want to find this, it's AH. Soccer. So AH cos. So cos 32 is equal to adjacent, which is x, over the longest side, 28. Do we agree? Cross multiply, it means x is equal to 20. You always write the side before the angle. X cos 32. You don't write anything on the side of the angle. It's always the side before the angle. And always remember that. So it's 28 cos 32. What do you get? 28 cos 32.
23.7.
20.
23.7.
Cos
23.
32. 23.7. Correct. Now let's look at finding y. Opposite or h sine. So it means sine sine 32 is equal to opposite, which is y over the longest side, 28. So y is equal to 28 sine 32. 28 sine 32. Sine 32. What do you get?
14.8.
14.8. Clear? I think everyone now is now comfortable. Maybe you just need to send you a worksheet over weekend to calculate this. Then the last thing that we want to look at is then the other thing we'll look at on Monday, on Tuesday, I think, on Monday, I'm not sure when we have met, is what we call sine rule. Sine rule. So, unlike Pythagoras and Soccer Tower is used for right angle triangles, this one is used for non-right angle triangle. Non-right angled triangle. Clear? Non-right angled triangle. So my question is, you're going to ask me, what do we use it for? Or when do we use it? Let me give you scenarios. When do we use it? So if you have a non-right angled triangle like this, if I'm given this angle, for argument's sake, let's say this angle is 66 degrees. And I'm told what this side is. Let's say this side is 14 centimeters. And I'm told that this side is 18 centimeters. This is just an example. And I'm told to ask to find that angle. Because I have a pairing, I have an angle and a side opposite the angle. Then I have a side, the angle that I want to find is opposite the other. So it's to do it pairs, like this. I can use sine what? Sine rule, clear, to find the angle. I can also use it to find a side. So to find a side, I'm sure I guess is correct. Let's say this is 50 degrees. And let's say this is 70 degrees. And let's say I'm given that this is 120 meters. I'm just saying an example. And let's say I'm told what that is. So because this angle is opposite this, and this side here is opposite this angle, I can use sine what? Sine rule. That making sense? Making sense or not making sense? You don't have to memorize the formula. I'll show you just now what you need to know. So let's look at examples. We'll look at 3 examples, then I'm sure you'll be sorted. We'll start with finding angles using sine rule here. Let me use your book so I don't like things from my head here. Sine rule. Okay, that's all done. Just want to use your textbook to sort this out. Okay. Now, so let's start with an example. So I'm going to write example 1 in your notebook. Example 1. Example 1 there. Example 1. So let's say we have so let's write this. You can write that find C. So this I'm taking from my textbook. Find C, then draw the triangle in a notebook. So this is the C that they're talking about. This angle here is 60 degrees. This angle here is 50 degrees. And this here is 7 centimeters. Can you copy that quickly then? 7 centimeters. You've managed to copy that? I done copy? Yeah, done.
Yes, sir.
So now let's look at certain things here before we look. This angle is opposite that, and that side that we want to find is opposite that. So you can use sine rule. So what we simply do is we say sine 60 degrees over the side that is opposite 60 degrees, which is 7, is equal to sine 50 degrees over the side that is opposite, which is what? Which is C. That's the first step. Huh? Clear? First step. Then now let's use cross multiplication, what you've learned. So it's C sine 60 is equal to 7 sine what? Sine 50. 7 sine 50. That clear? C sine 60 is equal to that sine that. Then the next thing is divide both sides by what? By sine. Divide both sides by sine 60. Because what I want is to find what? To find C. Huh? So I'm saying C sine 60 divided by sine 60 is equal to 7 sine 50 divided by sine 50 like this. Are we together then? Use your calculator. Oh, sorry, this is 60 here. Like 60, wait. Which one is 60? This is 60 here. So, okay. So this is 60 here. And this is my 50. Don't write wrong things. Huh? So this is 60 here, sine 60. So what do you get? 7 sine 50 divided by sine 60. We get 6 point what?
19.
6.19, huh? 6.19. Is that clear? Let's look at another example. Example 2. So that this angle here is 120 degrees. Then this is 15 centimeters This is 6 centimeters. Now we want to find an angle. Then we are asked to find this angle here. Angle X. So we've got pairs there. Angle opposite, side opposite that angle. So I'll say sine 120 divided by, this angle is opposite that side, 15, is equal to sine, the angle that we want to find, sine X, divided by that angle is opposite 6. Cross multiply, you get 6 sine 120 is equal to 15 sine what? Sine X, like this. Clear? That's step 2. Then you have to divide both sides by 15. What you want is to remain with sine X. You want to find what X is. And the X is the angle this time. So now we divide by 15, both sides. So that cancels that part. And I'm left with sine X. That gives me a fraction, not an angle. Sine X is equal to 6 sine 120 divided by 15. Clear? That's the second last stage. So to find the angle, remember this, if you use your calculator, you get a fraction, not an angle. To find the angle now, you say X is equal to arc sine. What you have been doing, arc sine brackets 6 sine 120 divided by 15, like that. Use your calculator.
$20.3.
20.3. If you have an old sharp calculator, I would encourage you to find this first. So what you simply do with an old calculator is simply do 6 sine 120, then you say divided by 15. Then when you have 0.3 something, then you say second function sine. You get exactly 20.3 degrees. Clear? Making sense?
Yes, sir.
Really make
Let's look at another example. Example 3. So if I have that, then I'm told that this is 52 degrees. This is 81 degrees. Then 81 is opposite P, which we want to find. Then this is 10 meters. So it means my B has to be in meters, because I'm measuring in meters. It's not up to scale, but we are using maths here. So we say 52 is opposite that. So sine 52 divided by 10 is equal to this angle, which is sine 81, is opposite B. Like that. Then cross multiply, I get B sine 52 is equal to 10 sine what? 81. Directly divide both sides by sine what? Because what you want is B. You're almost done. By sine 52. By sine 52. Then you're done. Because that cancels. So B is equal to what? What do you get from a calculator? 10 sine 81 divided by that sine. You find from a calculator.
12.5.
You're saying 12.5? 12.5.
5.
Yes, sir. Yes, sir.
4.5. What's the next lesson after this? ICT, is that correct? I think so. And ICT practical, I think. Maybe one last example. So I'm giving you a worksheet to try to try soccer town and sign rule for weekend there. Let's look at one last example. So example 4. Someone is having network issues, some network challenges. Okay, like this. So let's say this angle is 71 degrees. This angle here is x degrees, opposite 72, and this is opposite 100. So let's apply what you've learned. Sine 71 over the side opposite 100 is equal to sine, it's always sine an angle, x over its opposite 72. Cross multiply 72 sine 71 is equal to 100 sine what? X. Then divide both sides by 100. So I'm saying 100 sine x divided by 100 is equal to 72. I'm dividing both sides. Sine 71 divided by 100. So that this cancels. And I have sine x is equal to 72 sine 71 over 100. But that gives us a fraction. So the last thing is x is equal to x brackets 72 sine 71 over 100. Are we together? Let's try to sort it out. But even with a sharp, you can do that because you can use brackets. You say second fraction x and then you say bracket 72, it can work. Sine 71, yes, it works. Divided by, I hope it works. Let me see if it's correct. Don't trust my old sharp calculator. 72 sine 71 divided by 100. Then second function x. Yeah, it works. 42.9. Is that all you're getting?
Yes, sir.
N goes to 1 decimal place. Are we together, guys? That making
Yes, sir.
sense? Okay. Making sense. That's good. Okay. So we are done for today. So I'll send to Lila, then she sends on the group worksheets for you to work out for the weekend. And submit maybe Sunday maybe by after lunch. Yeah? It's okay. Clear?
Yes, sir.
Okay.